So before we do this one, we said the derivative with respect to x of e to the x is e to the x in a previous video. But you could write it like this. It's the same thing, right? Natural log means a base e logarithm. So what power do you raise e to make it equal to e? Well, it's just 1. So 1 times e to the x is e to the x. The whole reason I did that, I didn't just multiply by 1 for no reason, is because if we need to find the derivative of 3 to the x, then that's 3 to the x times natural log 3. Okay, so if you're trying to differentiate an exponent that's not base e, well, it's the same type of thing. The derivative is itself, but multiplied by this constant out here. It's a natural log of the base. So here, this derivative of an exponential function is itself times the natural log of the base. But we can't forget our old buddy, the chain rule, right? I took a derivative of the outermost function, the exponential function. Now there's something inner. I don't know what to say there. There's something inside, right? We can make it a composite of two functions, where this would be the innermost function of the composition. So we need to differentiate what I've circled up there and multiply it according to the chain rule. So in parentheses, 3x squared, the derivative there is 6x. Derivative of constant's nothing. Make that negative 2 come down. It makes positive 8x to the negative third. And now we're done. If we need to differentiate f of x, this one calls for the quotient rule, right? Derivative of the top function with the bottom function kept the same, minus the top function kept the same, times the derivative of the bottom function. So that's 3 to the x times natural log 3. Right? Derivative of the bottom function is this because the derivative of 3 to the x is 3 to the x times natural log 3. And then the derivative of 5 with respect to x is 0. And then it's all divided by the bottom function squared. So we can clean that up. Man, after some of the problems in this textbook, we're algebra masters, so this is child's play to us, right? So this is all one term. We could distribute it. So we can distribute that here, distribute that here. So 3 to the x times 3 to the x makes 3 to the 2x, or you could say 3 to the x squared because it's multiplying by itself, times natural log 3. And then here times this, we just have to have that 5 as a coefficient. And then we're supposed to subtract this. Now if you have 3 to the x times 3 to the x, that's something times itself. So 3 to the x squared, and then it's still natural log 3 over here. Now look, there's still a denominator here. The same thing with the denominator. But look in the numerator. There's something that can cancel out. Man, us calculus students love scratching stuff out and making it smaller. I think that's as simple as it can go. We got 5 times 3 to the x times natural log 3. You could reorder that so the natural log 3 is out front. But I think that's as simple as we can go.